So this is a talk that has a few different titles. We've been kicking around for a while. And you know, one way is to look at this, look at all the cool features in Java. Another one is from JDK 9 to 13 and beyond and all this stuff. I like to call this Java after 8. Or to use pictures instead of words, Java after 8. Okay, good. So that's what this is. This is the world after 8. So all of you are on 8. Virtually all of you said you're on 8. There are a few that are using pre-8, and like we said, we feel your pain. But this is about what is after Java 8, going forward, what you should be looking forward to, what you should expect, what's coming. And I'll cover a few different things there, both a bunch of, you know, just picking a few features here and there to highlight, and logic of change, but also talk about what it actually means to go into production after 8, what people have done, what people might be doing going forward, what the actual considerations might look like, because there are all kinds of things with this pace change that matter. So bear with me as I go through features. Eventually I'm going to get to some actual what can you do to take it to production and what we think the right roadmaps look like. So we've got a bunch of changes that have gone with Java. We have Java 6 that's now 13 years ago, and some people here are using it. And Java 7 came out a little over 8 years ago. So it's long in the tooth too. Java 8 is only about 5.5 years old. It doesn't seem like it's that, you know, it seems like it's longer than that. But the really cool thing, in my opinion, in 8 is it really took over the world very quickly, because it had probably the coolest developer-led feature drive in Java since probably Java 5 with generics, or util concurrent. Those two drove them. But I would say even more than those. Like Lambda expressions, people just like coding that. And like, you know, Java 6 had some features. In Java 7, you could save a little bit on the curlies and the brackets. But 8 was very material. It changed how we code. So great. Now after 8, it took a while, and then we got 9. And then we got 10 and 11 and 12 and 13. And we're going to get 14. We're almost at the halfway point between 13 and 14. Okay? It's going pretty quick. And you guys probably all know this and have heard many, many different talks about it. This will be just a little bit of perspective on it. And the good news is it seems to be going on track on the declared path, exactly on the declared dates, which I really, really like seeing. Things are coming out on the date that they were planned to come out 2 years ahead of time. I mean, they're not ahead of time. The declaration was 2 years before it happened. So good, but also heads are spinning, right? Because you guys are still an 8. And a few, like not just a few, but a quarter of you have actually gone to 11, but very few are only on 11. You're still in the 8 to 11 move. And 11's already been the past, sort of, maybe. So if we look at it from a map perspective, it looks like this. The long lines here are actually the Oracle declared long-term support releases. 7 and 8, 6 before that were long-term support. 11 is long-term support. This release will be around from Oracle and with community support from the community for quite a few years. It's going to stick around like Java 8 stuck around. But as I said before, 9 and 10 are dead. They were 6 months and gone. Nobody is releasing an update to Java 9 after 9.04 or to 10 after 10.02. There is no 10.03. You don't expect it, it'll never come. Well, you can build your own and maybe put it out there, but you know, none of the folks actually doing JDK seem to be doing that. We all know that we're going to do 11. We're all supporting 8 for quite a while to come. And we are here in this interesting desert. Between 11 and 17, 17 will be the next LTS. For those of you not tracking the numbers exactly, it's every 3 years there will be an LTS, and it revs every 6 months. So every 6th number is an LTS, assuming all keeps like that, 17 and then 23, and do the math, right? All these other ones in the middle are feature releases, but they're full-blown Java releases revs of the class file version, all the parsers will break, that kind of stuff. And they have interesting stuff in them, but they live for 6 months, then you gotta move, and you gotta move, and you gotta move, and there's no updates until you get to the next one. So in this kind of interim thing, and I predict that as a result of this, most of you are looking at moving to 11 and staying. Staying, running in production in 11, playing with the other things, then move to 17 and staying. Now, some of you will actually race much faster than that. Some of you are in this world where you control everything, you have a lot of guts, and you will take your production on the latest thing that's like 2 months old and run it in production, and if there's a bug, you'll figure it out, and you'll move forward or move backwards and change your code. But most stuff in the world doesn't live like that, because most software in the world doesn't have a developer attached to it. When you take that code and you move to your other job or to your other project, somebody else has to run it, and when the JVM version no longer updates and you gotta move to the new one and it doesn't work on it, somebody has to call a developer. I guess that's job safety, but say every 6 months is a little hard. So this is actually a problem, and I will come back to talk about it towards the end. But let's look at what we need to do to come up to speed. There are a few things here. First of all, the current Java is either Java 13 or 11, depending on whether you mean run in production long term, or the latest one that is out there is a GA version I can run today. And if we look at the changes, you got to look at the changes from whatever you're running right now until then. So if you're running on Java 8, then you need to look at all these changes to figure out what 13 is. What happened in 9, what happened in 10, etc., etc. So what I'm going to do is go over some of those. It's exhausting, you can't go over all of them, and I'll cherry pick a few, but we're going to go through some samples of what happened in each one of those, some highlights of interesting stuff in them, and hopefully that will be useful. If you really want to study this, you can study it in depth. My colleague Simon Ritter, who actually helped me put a bunch of these together, does these really cool talks on 55 new things in Java 10. And the cool thing is that's like an hour of 55 things in Java 10 you can learn. If you have the time, there are recordings from various shows that he's done those, and he's done those for 9 and 10 and 11 and 12, and now he's doing 13, so good. So changes. Changes happen in a few different areas. First one is to the Java language itself, changing how we write code, new syntax, okay? Or new, like, now you could write it this way, right? Then we have changes to the platform. So when I say Java 13, I mean the language, Java, not Scala, not Clojure, not Kotlin, Java, right? When we talk about the platform, we're talking about the JDK, and that includes what Scala and Clojure and Kotlin and Groovy all run on. And there we'll say, JDK 13 or Java SE 13. And there we're changing the specified APIs, what's in the libraries, the behavior of the code, the platform itself, things like that. But the behavior in a way that you can sense functionally, okay? And then we have OpenJDK, which is a specific implementation of Java, an important implementation of Java, because that's kind of where Java is actually developed, and the new versions of Java are kind of rolled out there. And OpenJDK actually provides the reference implementation for the Java spec. So when we nail down and say this is Java 14, there'll be an OpenJDK version that is the reference implementation for what that is, and we'll vote that it really is, and it will stay frozen. It's not the updates to that are the reference implementation. The reference implementation is frozen in time, but it comes out of OpenJDK, so it's important. But OpenJDK has a bunch of cool under the hood stuff, implementation specific stuff that have nothing to do with Java the language or Java the JDK or the libraries or the functional behaviors. They have to do with speed, things like garbage collection, pauses or not, speed or not, sizes or not, how fast you start, how you compile. Those don't change anything in your code. They don't change anything in your functional behavior. You can take your code anywhere, but hopefully they're changing it for the better, right? You're getting faster, better, smaller pauses, larger heaps, whatever you need there. But those changes should not be confused with changes to the Java SE platform, which is a specification, or to the language, which is a specific thing there. So as I go through things, you'll see all of these categories mentioned. Just keep in mind that they're not commingled. A change to OpenJDK's internal garbage collectors is not a change to the Java platform. We have people from IBM there with J9, we do Zing, various things, and just because some implementation changed one thing doesn't mean the platform changed. We all still run the same code. Okay, JDK 9 was probably the last really big platform change. Lots of changes, lots and lots of changes. Why was it the last? Because it was the first of the 6-month version. So after JDK 9, we moved to 6-month cadence. Only a few things changed, then only a few things changed. But JDK 9 was, a full shopping basket. And 2.5, actually 3 years, I think, of time between 8 and that. So lots of things in there. I got one thing in there. On spin weight is my fault. But lots and lots of cool different changes, and probably the biggest one everybody's noticed is the Java Platform Module System. And fundamentally, the JDK itself became modularized under the new module system. The biggest beneficiary of the module system is the JDK itself. It's actually what drove the modularization. Yeah, I sort of thought of what you might do with modules, but the reality is that JDK wanted to be modularized itself, and most of the design is driven by it. So the JDK is now broken into 75 different modules, and here's some stats about them. Most of the internal APIs are now encapsulated, so they're in a module. You can reach them if you lift the right lids off the modules, right? But modules provide a new layer of encapsulation and security or containing visibilities and such. And you can open up the can the right way. There was a lot of interesting back and forth before JDK 9 was actually voted in as a standard, with some open discussions about what it'll do to the ecosystem. And we actually saw a change. This is a place where you could see the community actually doing really good work, both in the OpenJDK world and open other communities, and in the JCP, which I'm on the JCP EC. We actually asked them to change the spec before we voted yes on it and open some things up, specifically around things like, access to sun, misc, and safe, various other flags, and what would the default be, what would the warnings look like, things like that. And I'm happy that that happened. It was it's actually a good example of everybody working together, right? And I think the hotspot developer guys did a great job on both proposing something and then listening to the community and adjusting accordingly. So JDK 9 actually had a big change around that. Another cool feature that some of you might have heard of is jlink. It's there from 9. Everything I'm talking about, almost everything I'm talking about, is from 9 on. So if you're running 13, that also applies, right? It's just 9 was the first place it happened. So jlink lets us basically take an application in a JDK and then combine only the modules that the application needs into a package, an image that is a smaller footprint. And smaller footprints are good for various reasons. One of them is they're smaller. But the other part is the notion that exposure is lower, right? If you don't need the code, it's not there. There's less attack surface. There's less bug surface, whatever those are. And if you look at how people use Alpine Linux, for example, it's usually not about footprint, it's about exposure. So it's the same notion. So jlink lets you do that. How people use it or not, it's still early to tell, because not a lot of people run 9, and 11 is kind of young. But it'll be interesting to see if people use this feature or not. Now, with JDK 9, a bunch of cleanups started, because Java is 20-some years old, and it's been carrying a lot of baggage. And whether you like it or not, and I'm on both sides of this argument, some of that baggage needed to go away. It's too costly to keep around. So JDK 9 is the first version of Java where things are starting to go away that have always been around. So deprecated APIs were actually removed from the platform for the first time in the history of Java. Until now, they just got deprecated, and you get warnings and ignored them. Some of those things you've been ignoring for a decade are gone. Okay, they're gone. You can't use them anymore. So you should have listened. But in addition to just regular deprecated stuff, we've had this evolution of big things being removed. So in Java 9, for the first time, the entire Java SEE aggregator module was removed. And I'll show you what that is in a second. Now then it was hidden. You can kind of bring it back with a flag. That's part of the debate we had back then. But in Java 11, it is gone. You can't bring it back. You got to go find an alternative on Maven Central. That's the same module, but without changing something, that code isn't running. JDK 10 and above will continue this work. This was not a one-time reduction or elimination. It was a policy change. From now on, things will start going away. You should watch your deprecations, and you should watch them closely. Now, more features will be removed in the future, not just APIs and stuff, but for example, the CMS garbage collection we just heard today is probably gone in Java 14, if not in 14, probably by 15. And a few other things. So things are truly going away. And again, it's baggage. 25 years of weight to carry around with people that aren't around anymore to maintain it is something you got to clean up after. So here's a statement about compatibility. And that sounds kind of good. Clean applications that just depend on the Java SE shouldn't just work. Now, unfortunately, the world isn't as clean as this, and the reason is this is an absolutely correct statement, but note the very careful spelling of Java SE. This refers to the module in JDK 9 that is spelled Java SE. There are tons of Java SE 8 things that are absolutely going away. So java.se lowercase doesn't mean Java SE the platform. So big parts of the Java SE platform are no longer part of the Java SE platform. And as an example, all of these are no longer part of the Java SE platform. Does anybody here use any of these? Direct. Does anybody here think they indirectly use any of these? Okay. Has anybody here used the base 64 encoder or decoder? Okay. Has anybody here used the JSON parser? They use base 64 encoders. Guess where they are? So there are alternatives. There are many other places to get base 64 encoders. This is not that it's broken, it'll never come back. It's just that you need a new version of a JSON parser that uses the base 64 encoder that doesn't come from here. Or you need to bring the Java SE module from Maven Central to add to your application because it's gone from the platform. Things don't just work. And that's a key thing. For those of you that have gone to 11, I assume you've run into these things. And here's the good news. As you saw here, people can get past this. So don't be afraid. Don't not do this. Please do this. We all need to eventually move to this stuff. Just be aware that it's not just a Java 6 to 7 or 7 to 8 like transition. After 8, there's a bigger deal to move on. You need to be a little more thoughtful and prepare for disappointment. Okay, so new version of Java may include breaking changes. Anything for removal will be deprecated first, so you will be told, you will be warned ahead of time. But in a minimum is 1 release of warning, but that sounded good when releases were 3 years apart. Releases are 6 months apart now. So things can go away in a year. From warning to it's gone, you have a year. Okay, okay, so 9. 9 was a big sea change. On to 10. 10 has a few cool things in it. I'll highlight a couple. Java has var. Why? Because it's sexy. Every other language that's sexy has var, so we should do that too. And I mean, that's one reason, I guess. But fundamentally, it's you write less code and you infer from the other parts the types that you don't have to spell out. And again, depending on your coding style, you may like it or not. The good news is you don't have to use it, right? I tend to not use it. I like to be able to read. I like to skip inferring in my brain. I like it to say what I say. But it's good to have it there for various reasons. And a couple of examples are you can propagate through. So those are simple. You just propagate and infer from right to left. But You can infer the type string in a loop because you have the type of the variable. You can infer an int, which I actually kind of am annoyed at because it forces you to put an L on the longs. But hey, okay. And then you can do some other things, and this is a good example, practical, of how it cleans up code. So for example, if you have try with resources block, which you should if you're doing good management around try blocks for I/O stuff, for example, that looks like this, you can convert it to look like that, and it's more readable. It's a little bit of cheating because we picked exactly the thing that'll fit on the screen if it's var, but again, in an ID you usually have a little more room as well. So I do think this cleans up the code. This is clearly more readable than the previous for what it does. So there's goodness here. Var is a reserved type and not a keyword. And why would you care? Well, if you're really into languages, you care, but let's get practical for what that means. You can write this. It's okay to have a variable called var. Why? Because it was okay yesterday, and we didn't want to break everybody's code, right? Therefore, it's not a keyword. But it's not okay to have a class called var with lowercase var. It is okay to have a class called var with uppercase var. If you had a class called var with lowercase var at the v at the beginning, you deserve this. Okay. I mean, yeah, it was legal yesterday, but come on, right? Okay. Okay, so var is here. So now you know what it means, and hopefully you knew before. Here are a few JEPs. JEPs are Java enhancement proposals, technically, from the OpenJDK process, not from the JCP, but the OpenJDK process. So you will see JEPs for everything from new language features, new platform features, or just new OpenJDK internal features. And all of those have a JEP. And as you can see here, we have the JEP for the local variable type is up there. That's an actual language change, right? You write differently. We have parallel full GC for G1. That's an under the hood thing, make G1 better. Application class data sharing lets us start up faster if we do the right things. And then experimental JIT and heap allocation and all these other things are under the hood. They're good things. Like thread local handshakes are great building blocks for future concurrent collection and maybe cool, less hurtful de-optimizations and things like that. We've had a similar feature in Zing for a decade now called checkpoints. It's just a name difference, but it's a very useful thing, trust me. So these are some selected JEPs from there. There are also a whole bunch of new APIs. So don't think that it's just a tiny little thing. Like I said, there's like 55 things in Java 10 you can look at. But here are some of the new APIs. You can do copy ofs and collections, which is very convenient, especially when you look at variations of, you start looking at how you build or do static and initialize stuff, or just a shorter handwriting for things. You can do unmodifiable, yeah, that's the right way to say it. Basically collections and stuff, and those are useful not just for semantic of, okay, I don't want to touch them, but potentially if you do this, you will get performance. So under various things or over time, the JIT compilers could understand things like this collection is not modifiable and therefore act on it and do better things with it. And we also have things like or else throw on optional. Anyway, a bunch of cool new APIs. On to JDK 11. Again, this is cherry picking, it's not the whole thing. We have more cool things we could do with local variable. And for example, if you have something that's written like this, you could change it to be like that. You could put a var on that S. And you look at this and you say, well, why would I do that? That's actually more text, right? Well, the reason you would do that is so you could do this, right? If you want to start annotating things in lambdas, you gotta put a declaration on them instead of putting the type declaration full there and then, getting very expanded declarations. You could just use var. So I actually think, for me, this is where I would use var. Like everywhere else, I would probably just spill the damn thing. But here, in order to be able to annotate the parameter to a lambda, I think this is a very useful way to do this. because in lambdas I tend to not type out the type, right? But I do want annotation. So to me this turns it into a much more widely used feature from a language perspective. Another cool feature that I don't know how many of you know of is we can now launch Java from a single source file, not just from an object, not just from a class. So for example, you could say Java, something not Java, give it parameters, and it will run that. Now, you could look at this and say, yeah, okay, cool, I can write a little demo, I can give people source code and they can run it without compiling it. What is it really useful? We can now do this. This is a shell script with Java source code in it. And this works. How many of you didn't know that? See, you learned, here's your takeaway for today. You learned that you can now write Java shell scripts. Cool. Okay, that as of Java 11. You gotta move to 11, right? Motivation there. Okay. So here are a few things about Java, other things about Java 11. Nest-based access control. This is one of those things that has been driving the JDK guys crazy and the Java compiler guys crazy and the verifier guys crazy, but you don't care about. It has to do with how we had to deal with nested things that spread across class files that were kind of actually nested in a source file, but access control. It does do a great job of cleaning up the stuff under the hood. But again, it's very under the hood. It's under the hood specification-wise, though. It's not under hood just for a specific OpenJDK. So this is a platform thing. Dynamic class file constants are similarly a spec thing. They again probably don't show up in the code you use, but very, very convenient for the people who produce bytecodes, produce class files. It lets us do things much more shortly, much more concisely, and it probably because of how it's written, it'll tend to have people declaring things in a way that JIT compilers could blow through better for optimization. So I really like it. But again, under the hood specification, Java SC platform change, that probably doesn't change anything you do. Okay. HTTP client, that's a big deal. Could you believe that we waited until JDK 11 to get an HTTP client in Java, right? It's actually a testament to how strong the ecosystem is, because everybody's had an HTTP client in Java. We just had the problem of choosing which one. Now there's one in the platform, so hopefully we'll end up kind of consolidating everything on it so we don't have as many choices, right? TLS 1.3. And this is actually probably the #1 feature I've seen that drives people to Java 11 because they need it, not because they like coding that way. So TLS 1.3 is about a year and a half old, I guess. It's getting adopted widely, and both for simplicity and some speed, but probably for security over time, it's going to become a driving factor, and 11 has it. It's the first version of Java that has it. So if you need a functional reason to move to 11 because the world is pushing you there, this is probably it. ZGC is a new experimental low latency GC. Experimental low latency GC. I explained yesterday what experimental means in one of my talks. Hopefully you heard. And then we have the epsilon garbage collector, which is really cool. This is the don't do garbage collection. It was initially motivated by wanting to measure the overhead of garbage collection. Meaning, don't do it, and then let's do it, and we'll measure the difference. Now we know how much it cost. But it turns out that some people actually use this. So there's some people in the world that write 0 GC code or very low GC code and are willing to run for a day with a large heap and don't want a single GC, and they're okay blowing up rather than GCing. And epsilon is perfect for that. So this is the run until you're out of heap and blow up GC. Okay. Yep. But it's there. It's in there. You could turn it on. It is very useful for measuring with short-lived things the overhead of various GCs, because you compare epsilon GC with other GCs on performance, and you've got your delta of how much you're paying for having that GC on or that GC or that. It's a baseline of 0. Okay. New APIs. We have some new I/O methods, interesting null methods, and for streams, these become useful later. I'll show you where is later. But being able to have null streams both for input and output is useful when you combine things together. And optional has a nice is empty, which is kind of the dual of is present. It's weird that we had one without the other. So the duality is fixed. Some new string APIs. Some new string APIs. The strip one is interesting because a lot of people look at this and say, well, but we already had that. Well, it turns out we already had it for some languages, meaning some, like English. But this is an actual true internationalization white space recognition stripping. So it's a more correct way of stripping in a string, right? Useful. String repeat. Say this 5 times. Yeah, it comes in handy in some things. I've actually used it. So I used to scoff at this and say, what do we need this for? Then a week later I used it. So I guess it's useful. Okay. This is a cool one. So predicate has a not method now, which is not predicate. And you think of how do you use that. So imagine you have this written. And you could say, okay, that probably is readable, but it's readable. It's got a bang instead of not. Some people don't think of that as readable. But you also have a full expression here, right? You write the whole S arrow thing just to get to say that it's not. With not, you could say this, which is more clean, right? You're saying it's a not of the is blank. And if you use import static, you can make it this, right? So this is just more readable if you're actually trying to say this is the not that without carrying the S through, right? So that's nice to see kind of the evolution of small APIs in this case that let you write cleaner code without changing the language. It just allows you to do the common expression in a more readable way. Okay, remember I said these are removed, right? Up to now, these were hidden. But in 11, they're gone. Right? There's no flag to bring them back. This is the I didn't mean it flag that we had in 9 and 10. Now it's gone. The good news is all of these are in Maven Central. So if you need them, you can bring them back. You just have to change your dependencies and all those. The namespace is the same, so you don't have to kind of change the code that uses them. But you do have to change something in order to build a working environment. Okay, so that was 11 on to 12. 12 has a cool thing called switch expressions, and it also introduces a much larger cool thing, or scary thing, depending on where you are, called a feature preview, or preview feature, sorry. The way preview features work is these are additions to the language that we're not sure are going to stick around. So they're warning, if you use this, your code might not work on the same version, and the next version might not even compile. And to be able to run with them, you have to run with -- enable preview flag, right? So if you don't do this, it'll say no, right? Won't compile, won't run. So that keeps you honest. You're using a preview feature, so you have to have the preview flag. It's kind of like an experimental feature, right? But it's useful to try new things and then see how they are, and maybe you can change them. Like maybe the spelling isn't exactly right, so you change them over time, and you're allowed to, as long as it's preview stuff. Once you take out the preview thing, it's in the spec and it's going to stick around for a long time until somebody deprecates it. And I don't think we've ever deprecated anything from the language. We've only deprecated APIs, and so deprecating a language syntax would be terrible, a big thing. Okay, so up to now, switch constructs were statements, and you guys hopefully all know all the how to write switch statements. I'll show you an example, but they're kind of clunky. They're the old C-style switch statements, and they look like this, right? You have the different parts of the switch. You have to remember to put a break everywhere because the default is fall through, and the fall through is really useful, like in the Monday, Friday thing. But if you miss one, you get really surprising behaviors, right? So you're going to either break or return somehow. There's a default. If you don't remember to do the default, you might actually be surprised at the outcome as well. Anyway, that's what a switch statement is. A switch expression See that this is a switch string that is setting num letters to something, right? And it's actually a common thing to see as a pattern. Switch expression lets us write this. We want num letters to be this thing, and it's a switch on the value that would be assigned to num letters. So it's a right-hand side statement, or right-hand side expression at this point, right? And nice, succinct writing with lambda-like syntax and that kind of stuff, right? So this is a nice, clean translation of the previous one, probably more readable, more concise, harder to get wrong, that kind of stuff. Do the annoying bugs, because the missing break in the switch, it's one of those annoying bugs that when it happens, you think you don't do it, but when you do it, it'll take you 2 days to find it. It's like the, if, like you had an if with 2 lines indented, then you forgot the brackets. That's why I always put brackets on ifs, because I've been burnt. And why I can't read Python. Okay, so the new style switch statement, this is like a new old style. So, okay, what if you want the old style, but you want a statement, like an expression? So you could do a break with a value, and that becomes the value that's assigned to the left-hand side. Okay, so that's new syntax, right? Okay, and then you can do even bigger things with code blocks, and they look like this. Okay, so again, lambda-like syntax, where at the end of the block you have your break with the value, and that's effectively like the return value from the block, right? That becomes the left-hand side assignment. Okay, other JIPs, Shenandoah GC, another experimental concurrent compacting collector, is now included in JDK 12. G1 has a bunch of nice updates that make it better. These are 2 under the hood things in the JDK. Remember, no change to language or specs. JVM constant API and default CDS archive. CDS is a really cool feature. Actually, I would highly recommend people look at CDS in general. App CDS and CDS are very useful for startups, making startups faster, not paying all that class load and verification time every time you start up. And if you're starting to do containers that come and go quickly and all that, you could shave a good fraction of a second off your startup time by doing this. Okay, another thing is streams now have these teeing functions. So you could do the teeing and the together of stuff into a byte function, and this actually is where you fall into interesting cases. Remember those null streams we had before? So when you want to tee things, sometimes you want to tee a null. I know it sounds weird, but you have a tee and you need to provide stuff, and you only have one. Well, give it a null for the other one. So this is where that null stream from before becomes very useful. And this is kind of an example of using teeing to do a very complicated way of deducing an average. But it is actually a way of deducing an average. Now, if you only had this many numbers, this seems like a complicated way to deduce an average. Why would you write it this way? If you had 1 million of them, okay, maybe not so much. But remember that streams can be parallel. So this lets you do parallelized computation on an average and a collection, which is not something you want to write by hand, right? So when you're wondering why write the complicated, highly abstract way, well, this lets you parallelize it. Okay, JDK 13. We have this. Again, why? Because all the other languages do. So. This is very useful. I mean, anybody who's ever written, a bunch of text blocks and all that, and aligned them, whether it's for HTML or for other reasons, this I'm very happy to see this. So this is still being worked on. What the final spelling here is like, is this exactly right? Is the indentation quite real? But it looks like this is highly useful as it is, I think. And note that the indentation is deduced, right? So basically, that's what you have there is the output of that, which is the intuitive good interpretation, right? So like what the offsets are based on where you start them and all that. I have heard interesting kind of corner cases where people have found that maybe want to change the way it's specified, but it's in there. You can play with it, and it'll probably evolve slightly. Switch expressions. Remember we talked about this? Remember I warned you what a preview feature is? Well, switch expressions written like this from Java 12 no longer work in Java 13 because that break has changed to yield. It was put out there, people gave feedback, it was confusing to see a break with a number or whatever other reason, I don't really know. And whatever drove that, now the syntax is different. Break with a number no longer works. That was an experiment. Oops, nope, take it back. Thank you for playing. And it's evolved. So this is the new way to write yielding values. But this stuff's still spelled the same way. Okay? So this simple, straightforward one is stuck around, but the way you spell the weird ones is changing. And when this stops being a preview, it'll be when, okay, that's really the syntax. Okay? But you just learned the lesson about what preview really is because it changes. I half think that they did that on purpose. Because, you know, it's one thing to say, hey, we'll do this, but we could change it. But doing it and changing it 6 months later, that wakes people up. Right? So now you know how to really treat it. It doesn't require deprecation or warning. It was preview to begin with. Okay, selected other JEPs, switch expressions we talked about, text blocks we talked about, dynamic CDS archives, even cooler CDS. ZGC has new uncommits, which basically means it can go elastic up and down. It could reduce the heap, not just grow it over time, which seems to be interesting in some environments where you have a lot of, you know, idle things sitting around. And then the legacy socket API has been re-implemented pretty dramatically under the hood, hopefully with both performance but also some robustness around corners that have been hurting people over time. Okay, so that was 13. So I went through a bunch of features. We're doing okay on time, great. Now I want to go from the features to what does it really mean to use them? You guys are all still on 8. I gave you a map of what might be fun here. But how do you go forward, and how do you go forward beyond this? So OpenJDK is great. OpenJDK is where all the source code for the JDK is developed. It's in the open, a lot of contribution, a lot of collaboration. Oracle certainly leads this with tons of effort. And we are seeing a lot of great community contribution and offers from there. You need to remember that OpenJDK is a source code project. The thing OpenJDK produces is source code. None of you run anything that's produced by OpenJDK directly, right? Every binary you have your hands on is a distro of OpenJDK. Think Linux kernel, Linux distro, okay? Somebody put those together. Unless you're doing it yourself the way you like, I think I know one of you does, then you know, that's your own distro. Then you have a distro and it comes from somewhere. And there are many of them out there, and some of them are well built and tested, quite a few, but some of them not so much. And if you want an actual concrete example, this is a posting I wrote a few months ago on the JDK mailing list. You're welcome to Google and find a very contentious discussion where I think the Debian community really hates me by now. Hi, Debian community. But fundamentally, somewhere between April and May of this year, about 10 million people ran a JDK that said it's updated and it had security bugs in it that were fixed in the release it said it was, but weren't in the build. That happened. Docker run Java 8 did that. How many of you run Docker Java 8? Okay, you did that. From April to end of May. There was a CVE 9 and a CVSS 9 and 2 CVSS 8.1 fixes in that release. There were high severity and critical severity, and they were not in the code, even though the code said it had the version that matched the OpenJDK thing. That is a bad build of OpenJDK. Now, we had contentious debates. I think those people will do it right next time. But what it means is there are lots of options. It's up to you to choose which one. Here's a bunch examples. And there's others I didn't list here. And it's up to you. You guys have a choice, right? Look around, check reputations, check history, make sure that it's a good one. And there are various good ones, including all these are free, right? It's just which free, right? And then there are commercial ones. Obviously, Oracle will have one, IBM will have one, Azul has commercial stuff as well. You can choose. So plenty of choice. So since you have plenty of choice, let me talk about one of the choices, which is Zulu. Zulu has many forms. The main form of it is a free, 100% free, 100% open source community distribution of OpenJDK. It's probably the longest, widest standing distribution of OpenJDK. We've got everything from 6, which we no longer update because old, but you can find Zulu 6, 7, 8, 9, 10, 11, 12, 13, and soon 14 EA. We have every version of every one of those built, tested, TCK'd on a CDN for the last 6 years. That's what Zulu is, and it's free. Go use it, right? Now, it is a curated distribution. Virtually every distribution is curated, okay? We take the pieces and all those, and think of it as we take all of OpenJDK as it is, and then we do things like support different bitness that might not be supported by it, like Java 11 on 32-bit, and doing ARM64 and 32-bit, stuff like that. But also some features that are not modifying the platform in any real way, but have been convenient. So for example, who here has played with Java Flight Recorder? A few of you. Who here have played with Java Flight Recorder on Java 8 in production? Good. Who here have done that on a non-Oracle JDK? Why? Because Java JFR only was open sourced in Java 11. Zulu 8 includes JFR. We backported Java 11 JFR to Zulu 8. There's an OpenJDK 8 with a free JFR in it. For those of you who like that, now you have it for free, okay? You have it for free in 11 from everybody. It is open source part of 11, but we backported 8 too because, hey, a lot of people still use 8. Similarly, we provide a TLS 1.3 support in Zulu 8 with a flag. You turn a flag that says enable OpenJSSC and you get a backport of the TLS from Java 11 available in Java 8. Because if all you wanted is TLS 1.3 and you still have a pain going through the other stuff, do this for now. I don't want you to not move to 11. Please do move to 11. But for the things that have a hard time, this curated distro actually lets you do that, and it's there. We also do a whole bunch of different builds. We actually build over 800 different things every quarter because of all these combos. So we have a JDK and we have a JRE, but we also have a JRE with JavaFX in it, OpenJFX. Who here uses OpenJFX? Okay. Who here thinks they might actually be dependent on OpenJFX? There. So here's an interesting story for you. The reason we have OpenJFX, JDK plus OpenJFX in is because the Oracle Java 8 has that. And it turns out that because it was there and IDEs could see it, there's some classes in it that people end up using, not thinking that they're JavaFX, because they were just in the JDK. You know what the most popular class is? The 80% case for people asking us for JFX? There's a pair class. It's 50 lines of code. It's a tuple. But the JDK does not have a pair class. OpenJFX does. So the most commonly used pair class in the Java world is the JavaFX one. Now there's 50 other ones you can find on the internet, but you're using that one. So we put an entire OpenJFX in the JDK just so your code will work for one class. Yeah, I mean, I gotta say I'm pretty upset about that one, but hey. It's one of those, we thought of just packaging the thing and putting one class in it, because it's fat, but hey, the good news about this is it means there is a way to say, oh, the damn thing doesn't work, I don't have to change the code, go get a distro that has the thing that's as compatible as possible. And the curated distro in this case is we're trying to make it as close as possible to move Oracle 8 to OpenJDK 8 without having to change your code. Okay, now on to the next part. MTS, midterm support, is a concept that we've created. We initially had it only on the commercial side, and we basically announced that this is now available for free for community for Java 13. Let me explain what MTS is and why it's needed. By the way, we are the last talk of the day, I believe, so I'm going to intentionally run about 5 minutes over. If you guys are angry at that, well, here's the door, but you know. Yeah. So why do we need this MTS stuff? JDK versions need overlaps. I'm sorry. In order to actually be able to use it in production. And here's an actual factual reason why. There are a lot of post-GA bugs that happen. Thank you to all you guys that have done Java 11 early, because you're making it better for the rest of the people. But in Java 8, there were this many bugs fixed after GA in the first 17 months. More importantly, in the 12 months after the first 6 months, remember all these things stop after 6 months, in the 6 months after, there were 1,200 bugs fixed in Java 8. They don't stop coming. They start coming when you start using stuff. And we're just now seeing the real adoption of 11, right? So production use remains in some previous version, and we need updates, bug fixes, security fixes for what we're running in production. So we need them to happen at the same time. We need overlap. And this is what overlap used to look like, okay? We used to have years of overlap when Java's, between Java 5 and 6, and 6 and 7, and 7 and 8. And then 8 to 11, we went down to 4 months. But now we're at 0. When Java 13.02 comes out in January, that will be the last Java 13 under current plans. And if you use it, then the next thing to move to is Java 14.0 or 14.01. The first one will be a day old, the next one will be 3 weeks old. And if you're stuck with something that doesn't work on one, works another, but this one's unstable, you're in a corner that's really hard to get out of, and good luck convincing your production people to let you run that. Which is why we think most people under the current plan will end up playing and waiting and really liking that switch statement. But you can code to it on your laptop, but don't put in any real code unless you plan to deploy in 17, and probably a year into 17 after it's solid, because look at how long it's taken people to get 11. We want to fix that. And the way to fix that is with what we call midterm support releases. Midterm support releases under our plan for community, and Java 13 is the first midterm support release we're going to do with Zulu. Allow you to keep running. We'll have updates, not for 8 years, but for 18 months after the next LTS comes out. They will have enough overlap for a soft landing into an LTS that'll last for years. So you can code to Java 13 today, knowing that there's a free way to deploy it and run it in production until there is a stable Java 17 you can move to. That's the entire purpose of MTS. And we've talked to people on and off about the need. We've gotten a lot of customer input for the need, basically saying we can't use this stuff unless we have a path forward. And I think in the last month we've announced that we're just going to do this for the community. We're hoping to do this as part of OpenJDK 13 updates in the OpenJDK project. But regardless of whether the community does this together or not, Azul is doing it because we're doing it anyway. We've got contractual commitments to do it to customers, so may as well do it as a free community thing as well. So that's the interesting news about Java going forward. Java 13 is something you can use forever. Don't those feature preview things, be careful, but but you can use it and you can write it into an overlap. You can move to Java 17 if that's the step you want to take. We will do the same for Java 15. And notice how Java 15's length is shorter than 13. Because its goal is 18-month overlap with an LTS. So that's out there. Hopefully you guys will get to use it, and hopefully that makes you like Zulu. Zulu Enterprise is basically the classic, here's the free cool thing, I told you what it is, here's some commercial good support for it if you want to pay for that kind of stuff and you like us. We do releases, both MTS and LTSs. We do them fit for long-term production use. We take care of things like separate security-only updates and separate bug fixes that are not security. So if there's an urgent security thing, you can deploy a security-only update and not have to take the 130 other goodies with it. We have all the indemnification on contamination, and we're very widely used across multiple industries. Here's a few samples just to give you a power view of that. It's not a tiny thing. Lots of people run this, run their businesses on it. This runs on it. All of this runs on it, both internally and all customers. And for 7, 8, 11, and 13, this also runs on it. Okay? So very often the silent choice under the hood that you don't even notice is using it. For example, who here has been playing with GitHub Actions? The new CI/CD thing on GitHub? It's in beta, but coming out in the next few years, not beta. Take a look at it. But it defaults to use Zulu as the JDK, so all the tests are done in Zulu. Okay, we do all these versions. We'll do the next ones. We'll do 24/7 support, etc. And for summary, Java is in good shape. It's been moving, and we've had 8, and 9, and 10, and 11, 12, 13, 14, 15, right? And we have the concept of LTS, and it sits here and there and there. But now we have this new concept of an MTS. And that's what Java after 8 looks like. Okay, well, thank you, everybody.